So let's look at how to do some basic analysis with time series data. So I'll be looking at how to import the data correctly, how to draw some standard charts, and how to do some basic transformations of the data. So importing, first of all, the necessary packages, NumPy, Pandas, and Matplotlib, as I've done before, like that. Okay, so the data that I'm importing is some quarterly data on debt to GDP ratios of a range of European countries. So here's the actual data. So as you can see, it's debt to GDP ratios, as I say, for these countries here. Notice that there is a column here showing the dates, the quarterly dates here. Now, in fact, this data was downloaded from Eurostat, and so this is the format by which it supplies the dates. Now, in fact, these are not suitable for importing into Pandas. Sometimes the dates that are automatically supplied when you access data are okay. In this case, they're not, even though they're perfectly fine as they stand, but they don't conform to the Pandas style. So I tried importing this data and setting this up as this of course will be the index, the time values, and it didn't work. So what I had to do was to first of all create my own suitable index series using the date_range function in Pandas, and for this you need to specify the start date and possibly the end date if you wish, or alternatives I've done here, the number of periods and the frequency. So as you can see, my data starts from 2006 quarter 1 and goes up to 2014 Q3. Now that is 35 periods. So I set 2006 as the starting date, and 35 periods and frequency of quarterly, which is QE. The various options you can put in there for monthly, annual, and so on, you can get from the help page. So this creates an index, which I will then use as the index in my data file. And so if you want more information on this date range function, obviously you can press Shift-Tab in the usual way and see the options. Or as I say, go to the Pandas website and look up this function, as I've shown before, and get some information there. But it's usually fairly straightforward. If you know the start date and you know how many periods and the frequency, that will work fine. So if I run this and we have a look at the index file, you'll see the format that Pandas uses, which is why the format in my CSV data file wasn't appropriate. It uses this format for quarterly data. It uses the full sort of end of period date. So the first quarter ends on the 31st of March of that year, and of course my first year was 2006. So if you were going to put in the start date and the end date rather than the periods, you would have to put the start and end dates in this format. So now I can read in my data, but I don't want that first column, which remember included the time values put in by Eurostat. So I've got an extra option here, an option that I haven't used before, which is this, use cols, which obviously stands for use columns. So I'm telling it to use columns, and you put it as a range from column 1 to 11. Column 0 is remember in Pandas, in Python, indices start from 0. So this time column here is column 0. So that's the one, I only want 1 through to 11. So that will tell it to ignore that first column, because I'm going to, of course, replace that with my own index. And so here, as you can see, once I've imported it, I then set the index property to the index that I created. So running those two commands, we should get the data correctly. If you wanted to know what the data is, what data format it is, you can use the dtypes property here, Obviously, they're all going to be, since they contain decimals, these values, they'll all be imported as float variables. You don't really need to run this property if you don't want. So let's have a look at the data. So using the head function just to look at the first 8 rows, as you can see, it's exactly what I wanted. I've got all the data in, it ignored the first column, and then I've put my own index variable in. So that's got the data in as required. So in order to get time series data into a pandas data frame, you may have to create your own time index variable if the one that's in the data file, assuming it has one, is not suitable. If it is, fine. If not, you need to create your own. And this is the function that you use. That's very important, of course. If you don't get the data inputted correctly with the time index, you're not going to be able to analyze it correctly. So just having a look at that's the beginning, which shows that it's starting from 2006 quarter 1, as it should. It should end, of course, in 2014 Q3, so we can use the tail function just to see the final 8 rows. And there we are. There's the final one. It's always useful, of course, to check that all the data has been imported correctly. So my data frame looks fine. Now, what I might want to do typically, first of all, is to chart this data to have a look at it. So let me chart these various variables. Now I want to chart all of them to begin with on a single graph. So I'm going to just use the plot function on the entire data frame here. We've seen this plot function before. Notice this time I'm not having to specify what type of chart, because by default it will be a line graph. Remember when I wanted to plot a bar chart in the previous videos, I needed to put plot.bar here. You could put plot.line, but it's not necessary. It's the default. So that's going to plot them. I'm using the title function here as always to give me a title. Notice this time I've also specified this option LOC to put the title over to the left rather than in the middle. The legend function I'll come on to. I'm just going to, in fact, comment that out to begin with. So you can see what happens when I don't have that legend function set. And then I can show the chart. So as you can see, we get is it 10? I think 1, 2, 3, 4, 5, 6, 7. Yeah, all 10 variables plotted on a nice looking ggplot type chart. But notice the legend is not very well placed. It's over here. It's obscuring these two here. I need to replace that. So that's why I've used this legend function here. So I'll uncomment that. So we've seen this legend function before, but here I've used this bbox to anchor option or parameter. What this does is it places the legend outside the chart. Notice here there's no real room within here to have this legend, so it would be ideally placed, say, here, which is what this option does. If bbox to anchor, if you specify 1, 1, it will put it up here at the top right corner. If you specify different values, it would be in the middle or down here, but I think up here is perfect. I need therefore to give a title to the legend, its country. I suppose that wasn't strictly necessary here, but I put a title. There are options to format it, so I've used this shadow option just to give it a little offset shadow. So let's run that and see what we get. And this time, as you can see, it's much better. The legend is not obscuring the data. It's nicely situated here. It's got a nice little shadow to it. I think that looks pretty good. So if you're plotting a graph and the legend is not really fitting within, because by default it will put it within the chart itself, if it's not really looking appropriate, if it's obscuring data, you can always use this option here to push it outside. Now, one thing you might want to do, of course, with a large data set like this is not necessarily plot all 10 variables on a single graph, because it's a little bit crowded. Here, for example, I might want to exclude Greece here and Italy because they are to some extent outliers in that they, even before here, 2008 was the financial crisis which caused these government debt to GDP ratios to rise significantly. Before then, if you know anything about that, you'll know that it doesn't really matter. But before then, Italy and Greece were to some extent outliers in that they had already very high debt to GDP ratios, over 100% anyway, unlike most of the other countries. So you might want to exclude those. The way you can do that is to use the drop function. Now you could use this drop function here to then store the remaining data in its own separate variable, which you could then plot, or as I've done here, simply plot it directly. So as you can see, I'm dropping columns at Greece and Italy, those two variables, with this columns function. Notice, of course, the variables have to be in a list. And then that will, whatever's left, which will, of course, will be the other 8 countries, I'm plotting in a line chart. Notice I've used an option here within the plot function rather than as a separate plt dot function, which I could have done to set the X label, a title, again, the legend outside, and then show the chart. So there's, as we've seen, very basically the same chart as above, but excluding Greece and Italy, which makes it a little less crowded and also means that those 2 countries, which to some extent were outliers, are being excluded. So very easy to plot a line chart here with the plot function. By default, it plots a line chart. You can format it nicely using these various functions we've seen before: title, legend. We've also seen how to use xticks and X label and Y label. Say the legend one here is particularly useful because it removes the legend. This particular option removes the legend from the chart where it was obscuring the data to outside. It looks much better. Now, how do you select particular rows and columns? Well, we've seen how to do this in the basic skills videos. The same techniques apply here. So to select a particular row or rows, of course, you use the LOC function and put the index in double square brackets here. Now notice the index, of course, in this case is not a number. It's the time value. So here I'm just going to select the row containing data for the first quarter of 2013. So that will return that, as you can see. Obviously, if I just wanted specific columns, I would just simply add those here at the end in a list. Again, we've seen this syntax previously. You can, in fact, use numeric index values if you wish, rather than the actual time values. I think this is preferable. In which case, because the number is not the actual index, you have to use the iLOC function. Not just LOC won't work. So if I wanted to just look at row 10, and remember the rows start from 0, you can use that, select that using iLOC function, and again double square brackets. That will select row 10, which happens to be the third quarter of 2008. If you want to select a range of rows, of course, well, we've seen how to do this before using the splice operator, the colon. Again, you could either use the actual index here, in which case it would be LOC, or if you use a number, then as I've done here, iLOC. And remember that when you specify a range, you don't actually need square brackets. So this is going to select row 7 to, well, if I'd specified another number after the colon, obviously it would have been 7 to that number. But if you leave it blank, it means all to the end. So this is going to select row 7 onwards to the end of the data set. Like that. So here's row 7, that would be quarter 4, 2007, and then the rest of the rows up to the end of the data set here. The reason why I might want to choose that if I was looking at this data is that this was the period just before the financial crisis and the ensuing global recession set in, which had a big impact on debt, on government debt to GDP ratio. So that is kind of a useful starting point for looking at what happened. So obviously, if you wanted to focus your attention on this particular data set, it would be best, of course, to store this subset in its own variable. So set this thing equal to some variable, and then you could use that from then on. Let's say if we wanted to plot this subset here, well, this is very easy. Of course, we've already seen how to do this. Just use the plot function on that particular subset with the same options as before. And we get that. Obviously, just the same type of graph, but this time it only comes from, again, I've used all the countries here. I haven't excluded any, but it only goes from 2007 quarter 4, as you can see. What you might want to do, of course, is not plot every single country on here. We've seen how to drop some. What if you just wanted a certain selection? Well, that's easy enough to do by selecting those columns in the way that we've seen before using this standard syntax here. But what if, in fact, you also then wanted to plot each country's debt to GDP ratio on a separate subgraph so that you had 4 separate subgraphs all contained within a single chart? Well, that's easy enough to do with the plot function using the subplots parameter, the subplots option. All you need to do is to set subplots equal to true, choose the layout you want. This is the number of rows, that's the number of columns, so that will give me a 2 by 2 grid, which I think would look best for if there's 4 subcharts. You could have you could put 3, 1, in which case it would put 3 at the top and 1 underneath, or 1 and 3, but I think 2 by 2 is obviously the best one here. You can set within the plot function, you don't necessarily need to do it separately as I've done up here. You can set it within the plot function, and that will set a title for the overall chart. And I've set the X label here within the plot function. The other thing here is this fig size. You do need to specify a size for your figure, and you need to make sure that's big enough to contain all 4 subplots so that they're displayed correctly. There's a bit of trial and error involved here. These values, I believe, are in inches, which presumably would be more relevant if you're printing out the chart on a printer. But nonetheless, you have to set these sizes to make sure that it prints on your screen correctly. So as you can see, to plot some subplots, 4 separate charts, 1 for each country here, within an overall single chart, so on a 2 by 2 grid, use the subplots option, choose an appropriate figure size and layout, and this should work. Now notice here I'm not using the standard PLT show option, and the reason is I found that if I did that, then when I actually save the figure, and here I'm actually showing how you can save a chart. I haven't looked at this before, but say you wanted to save this chart in a separate file, so you could then put it into a document or into a presentation, then this is how you do it. It's very easy. You just use this save fig option here, so plt.savefig, then in brackets give it a name. Now if you specify the extension here, in my case PDF, it will save it as that type of file. There is another way. I think there's an option you can set to set the format, but I think the easiest way is just to simply put an appropriate extension here. Notice there's no path here, so it will store it here, of course, in the working directory, which is fine. What I found, as I say, is if I also use the plt.show command here before actually saving it, then it didn't actually save the chart. It created a file, but when I looked at that chart, there was nothing in it. I don't know if that's me doing something wrong or a bug, but anyway, the solution is not to use PLT show in this case if you're actually going to save the file at the same time. It'll still display on the in your notebook fine, but it will also mean that your chart will contain the actual chart. So anyway, let me run these and you'll see what we get and what I mean. Okay, so as you can see, there's my nice little 2x2 chart with these 4 subplots, one for each country. There's a nice little sort of legend here, fine. There's my overall title and my X label, which notice it's put underneath each column with the years. Notice it doesn't put the years and the title here. Now, there may be an option to do that, although I think here it's better not. I think it's fine as it is because you've already got the years in here and it's clear. And because you've got the grid lines here, you can easily see what year is here. This is obviously 2009, 2008. I think it actually looks neater this way. But if you wanted the dates under here as well, then you'd have to look in the help to see what option would do that. But I quite like it the way it is. Now it should have saved a PDF of this chart in my home directory. Let's have a look. Remember that it doesn't always appear immediately here. You have to wait a few seconds or just refresh the page. There we go. Just wait a few seconds or it will do. There it is. Now if I double click on this, we can see that here's my PDF chart. You could, of course, simply go to the folder on your hard drive in Finder here, in my case on Mac, and go to this folder in Finder and open it there in Preview. But it will actually show in your web browser. And you can see we get a nice chart. Now the advantage, of course, of saving it as a PDF is a vector graphic file, which means, of course, that you can resize this chart to any size you want and you won't lose any resolution, unlike a bitmap. So I think it's best to use a PDF as the preferred format. But you could save it as a PNG if you wish, or a JPEG, just by putting the appropriate file extension. Okay, so that completes this first video on time series analysis, looking at how to import the data, how to set up the index variable correctly, and how to do some basic subsetting and basic drawing of charts.